I told you, you guys, are going to get tired of the GPA ACT stuff. It's going to show up multiple times because it's a nice small set of data. So, we're gonna learn how to find R, and R tells us the strength of our relationship. So, you're gonna look at, I kind of just said all this, sorry. So, to evaluate strength, we look at, excuse me, the correlation coefficient. Correlation is just a fancy way to say relationship. And the correlation coefficient is R.
Isn't it like as you're closer to 1, it's more strong?
So correlation measures the strength and direction. So two of the things when I ask you to describe a scatter plot are given by R, strength and direction. The only thing is R only works for a linear relationship. You can put all the data in, and if your relationship is curved, the calculator will still give you an R value, but it's not a good measurement of the strength of that relationship because it's curved. R is for linear. And we're looking at two quantitative variables. So we're still working with GPA ACT data, which hopefully should still be in your calculator. If it's not, it's okay. You guys are going to hate me. I'm going to make you do it by hand first. That's what, do you not see this table that we're going to fill out? All right. So, the first column is the individuals. So we have 6 students where we have their GPA and their ACT. So I'm going to call this kid student 1, student 2, student 3, student 4, 5, and 6. So just to keep track of which kid we're working with, we put the individual. Yesterday, Eric told us which one was X and which one was Y. Do you remember, Eric? Come on, Sam. All right, GPA is our X. ACT is the Y. So we're working with this student. He had a 3.0 and a 19, 3.5 and a 27, 3.1 and a 22. I don't know why I lost track of where I was in that small table, but I did. Alright. So now, notice that we need to, what is this formula? Anybody remember? It's a z-score. So we're going to find the z-scores for all the x's, so all the GPAs, and the z-scores for all the ACTs. So that means that we need to know the average GPA and the standard deviation, the average ACT and the standard deviation, which hopefully you still have your lists in there, and that's a one variable stat. Remember that from before. So you're going to find all the summary statistics for your list 1, summary statistics for list 2, so we can have our average and standard deviation. You should be working in your calculator. Not daydreaming.
Oh.
Oh, look at that. It should still be in there from yesterday.
No, we had the boats in.
Oh, we did put the manatee and the boats in there yesterday. Sorry. So put your GPA and ACT in there.
It was so sad having to.
It's only 6 pieces of data. It's not a huge amount to type in.
Oh, I thought of that.
Are you laughing at me?
Oh, Sam.
So I didn't hear what he said. Did he send you another video of me with the bald head? By the way, I got to see that video of me later in another class period yesterday. They're like, look! I'm like, yeah, I know.
Am I suspended now?
No, you didn't put a bullseye on.
Oh, yeah, that's why I got it.
All right, do we have our averages and our standard deviation? Hopefully.
That does not look right.
I see some nods. Yeah, the 1 bar stats. 1 bar stats. All right. So, who wants to tell me our average GPA? Let's see.
3.4.
Thank you. 3.4. And what about the standard deviation?
0.4.
Thanks, Eric. And then what about the ACT average?
I didn't get that.
24 is what you said? Okay, not going to agree. 24 is correct. Just wanted to make sure I heard you right. Like I'm listening for 24 because I know that's the answer and then sorry. All right, what's the standard deviation? Thank you. I heard 4.8 and he added the 2. 4.82. Now, it's up to you guys how you want to find the z-scores. Trying to think. You guys want to see a cool way to do it? I don't know if you'll like it. Go into your lists. So go stat, and we're going to edit. Anybody familiar with Excel?
Yeah.
Okay, so the calculator really is just Excel miniaturized. So I can go over here and define list 3 to be a formula. Yeah, so I'm going to define it to be the z-score. So we want to find all the x z-scores or the z-scores of the GPA. So that first x is all our observations, right? So all our observations are in list 1. I'm going to put parentheses just so I make sure the calculator does the top part first. And then I'm going to tell it to take list 1.
Wait.
Second one is how you get list 1. And then we're going to subtract the average, which you guys told me was 3.4. And then I'm going to close the parentheses. And I'm going to tell it to divide by 0.4, the standard deviation. Second one is how you get L1. And then once you have that typed in there, you just hit enter and it should put all the z-scores.
Mine's an error.
All right. So get back. So you have, I know what happened.
Oh, I figured out that we were on the. actual-
Yeah, if you're in the first
Oh.
little thing in here, it's gonna tell you error. You have to actually highlight L3 up at the top. So then parentheses, list 1, so second one, minus our average at 3.4, close the parentheses, and then we're gonna divide by 0.4.
Oh, there we go.
And then when you hit enter, it should put all 6 z-scores in there for you.
That's so useful.
This would have been so nice on the test.
Oh my god.
I mean, I'm still doing this.
So you should have a
I'm
caution
trying to
tray.
like put it in so I know how to load this.
Yeah, I did all right. Good job.
Are you ready?
Yeah.
Parentheses, list 1,
Minus.
minus 3.4, close the parentheses.
Okay.
Divide by 0.4.
Okay.
You have L3 highlighted.
Yes.
Hit enter.
Enter.
You have those numbers now. Okay, show a thumbs. We good? Okay, so now you can fill in your table. And then we also, excuse me, want the z-scores for the ACT data. So you can do the same thing in list 4 and define it. ACT is in list 2. So make sure you have L4 highlighted, not the first little entry. Parentheses, list 2, because that's where the ACT data is, minus 24, my average, divided by 4.82.
Aha.
She's gone for a week.
Thank you. This one.
Yeah.
Bailey's fingerprints where to go.
Okay.
She wanted me to tell you.
Thank you for letting me know.
You're
All right, so I put in my z-score numbers for the x. Those of you that are still putting your calculator stuff, Trey,
Yeah, true.
do you have your z-scores for your y's?
No, just a second.
Okay. That's what you want to have in there.
Yeah, true. Shut up.
Are you still playing Minecraft?
Well, there's an Enderman after me. That's a big deal.
What does that mean?
What is it?
Something about something after him.
Wait, 0.82. Big turn. Oh, it said error.
You weren't on L4 then.
What? I cleared all of it.
All right, so you should get z-scores like that.
J or
Wasn't the top.
So we have
Wait, so I do L2.
our
the negative
You know what?
z-scores for both x and y. And if you notice that last column, is your z-scores multiplied together.
Here you go. So could you just say?
So we're going to define list 5 to be list 3 times list 4.
Already did it.
Did it.
Boom.
Where is that?
Yeah.
Imagine you could
There's some big numbers.
All right. So this
It's these things.
is your z-score for x times your z-score for y. So we're going to define list 5. Make sure you're on L5. And we're going to define it as list 3, my z-scores for x, times list 4, my z-scores for y. and I get the numbers I need for my last column.
Not need this class.
But your list. Yeah.
That's pretty sad. Wait. So now we're combining the both?
Uh-huh.
So,
List 3 times list 4.
go this side. So we do.
Doctor, how do you go to the
There's 3 times 4. Wait, you're up.
I hate that too. Like, I got an issue. Who are you talking about? In what class?
Did you get?
You go to where? You say Applebee's?
Okay. Started Valley. No, I ordered.
You just do,
Alright, we good? Now, the next step is to add all these numbers together. You can do it by hand, it's 6 numbers, or if you do your 1 bar stats, it'll give you the sum in there. So if you go to 1 bar stats and put list 5 in there,
whoa.
that second thing that I said we'd like never use, this is one time we'd use it. We want the sum of all our x's in list 5, so that second number there just took all these values and added them together for us.
Wait, how do you do that?
1 bar stats.
How do you do that? It's
Stat.
just press stat.
Go over to calc,
The sum.
Calc,
and then list 5.
1 bar stats.
1 bar stats, list 5.
Calculate.
Put list 5 in there.
Come on, y'all.
Alright, so the sum, which is what this symbol means, it means we took the sum of everything. Why is it all yellow? Remove my calculator. So we took the sum of our z-scores multiplied together. I'm just going to rewrite it. You don't have to write it this way. Do you have to memorize this formula? No, you don't. I just want you to know what we actually do when the calculator finds R. It's taking z-scores and multiplying them together. Then it adds all your z-scores up, which gave us 4.77.
Yeah.
Oh.
And then the very last thing it does is it divides by the number of data points minus 1. So we had 6 individuals, so it's going to divide by 6 minus 1. So we're going to take 4.77 divided by 5. So the correlation coefficient between our GPA and ACT scores for this data is 0.954.
Yeah, like,
Why did you do,
Yeah, can you please do that all over?
that made no
why did
sense.
you do 6 minus 1?
Yeah,
That's the
Why is
formula.
that an E?
Where is
It's called degrees of freedom. We're going to write it right there.
Can we like explain everything we just did like right on paper?
We took our GPA, found the average standard deviation, found the z-scores, right? Same thing for ACT, found the average standard deviation, found our z-scores. We take our z-score for the GPA times the z-score for the ACT, that gave us this. Then we added them all together, that's what that symbol means.
Oh, you added all what together?
These 6 numbers.
You just add them all together.
Yeah.
And then you write the.
And that gave us 4.77.
Okay.
And then the formula tells you to divide by 1 less
Where?
than your number of theta.
Like not, what's 6 minus 1?
There are 6 pieces of data,
Get it.
and
Get
you
it.
take 1 away to make it degrees of freedom. It's just the term they call it. And you divide by 1 less than the number of data
So
pieces
that
you
little
have.
E looking like is
Summation.
4.77.
That just tells you to add.
6 minus 1?
No.
If there's 7 of them, you have to minus 1. And then
But it's always be minus 1.
Yes. That.
I literally just started paying attention to 2 seconds.
I'm still gonna draw that shit.
You don't have to memorize the formula. It'll be on your formula sheet. You don't need to memorize it. What?
Dude, it's so weird. I really do.
What is it, Calvin? Spit it out.
So the 1.7 said, is it this number? It's N.
I don't know how we got it like right there.
I mean, so what's that 1?
Oh my gosh, it's so good. Well, I don't know what that one is. We did that one.
So this is what we just did. That's the formula for R. That's how R is found.
Oh, nice.
You don't have to memorize it. You do need to understand what you're actually doing. Z-scores tell you what? How far away from the mean you are. So correlation tells us how closely we fit a shape, such as a line. And the best way to do that is see how far away from the mean you are. And then we figure out how far away from the mean we are with x, same for y, and we multiply, and then r comes from adding those together and dividing by 1 less than the number of data points you have. Z-scores tell you how far away from something you are. R tells you how closely you fit a shape. It's the same idea, just one variable statistics had just x. Now we have x and y, so we had to have a new way to measure it. You will see this formula. The biggest thing I want you to know is not to be freaked out. It's going to show up on formula sheets. Don't be like, oh my gosh, what is that? Sit down.
What's the 1 above the N minus 1?
That's how they write division on the formula sheets. Instead of
That's just example.
Instead of putting the whole summation thing of the z-scores of x times the z-scores of y over n minus 1, they write it as a fraction multiplied in front. So if you took 4 and you multiplied by 1/2, you get 2, right? So instead of writing 4 divided by 2, they just write it that way. It's just a different way to show division.
Wait. Should we write all that and you just tell the left?
No,
No.
you can if you want, but you don't have to. All right, so now I'm going to show you how the calculator does it, because none of you want to do that every time, right? No, nobody? I think that'd be cool. Actually, hold up, I had to do that back in the day. All right, new set of data. Don't be that mad at me that I'm making you clear lists.
Oh no.
Wait, we're clearing it?
We're gonna work with some college football data.
Are we actually clearing it?
Yeah. Just 2 of them. You can pick any 2 if you want to leave the first 2 lists in there because I said GPA and ACT will keep showing up.
Oh, sure.
But
All I get the list.
stat edit.
Well, come on.
I want you guys to put points per game in one list and wins in another list.
So I press delete or clear.
Highlight L1, L2, whatever list, clear, enter. If you hit delete, the whole list disappears.
But are these numbers accurate?
They're a few years old.
Wait, so just clear list 3, 4, and 5.
Sure. I mean, when I have GPA and ACT on the next set of notes, entering 6 pieces of data really isn't that difficult.
That's pretty much deleting all of them. Scratch. Respect.
I don't like that.
Who's the loud ass teacher next to us?
Weinberg.
Don't love library.
He was my economics teacher in high school.
Whoa.
And now you're teaching with this?
Yeah, Mr. Carrick was my world studies and American studies and my basketball coach.
Why did they switch?
Because of immersion.
I don't know.
Did you go to school?
So I don't teach algebra 2 every year. Some years I teach pre-calc. Some years I've taught algebra. The only one that I always get is AP Stats because I'm the only one who's gone through the training for it.
You're sad.
Yeah. I wanted to be like softy.
Shut up.
But I think because that way you don't get too stuck in your ways. I mean, I personally like changing things up because it makes me use my brain. All right. Well, no. But if I taught algebra 2 all the time every year, exactly, it would get really boring.
All the freshmen.
Algebra 2 is not bad, but doing it every day for years on years on years,
Get bored.
you would get bored.
I had it last year. It was fun.
Right, it is fun. I'm not saying it's fun. But,
Alright,
all right, are we good?
let's get this.
So, one thing I want you to be aware of, it's shown up a couple of times, and some of you have asked me about it. In your homework, I can't remember which number, but it's going to say use the 4-step process. And some of you have noticed it before. I personally don't find it useful to teach until later in the year, but what it stands for is state plan do conclude.
This was on our study guide.
Yeah, I personally don't find it useful till later, but really it's, do you guys remember doing math work samples?
State plan.
No, how do you do it?
And you had to, you guys probably haven't done them in a long time because COVID. But we'd give you a problem and that's it. We couldn't tell you anything. And yeah. And you would follow, I can't remember the acronym you were taught for that one because it's been a while. But it was Q something because you would restate the question. And this is pretty much it. They just made it for statistics. So you state what the question's asking you to do. You come up with a plan. You do the plan. And you make your conclusion. So anytime it references the 4-step process, that's what it means. I will not make you actually write out state plan do conclude until later in the year. So, first thing I suggest you do is start with a graph. Do we remember how to make our scatter plot from the other day? I saw some no's. That made me upset. Those of you that said yes, thank you. If you remember how, do it. Make a scatter plot. Are you boys listening? You ready? You got your data in there. Second y equals.
Second, y equals. Where is it?
Plus.
Second.
What's X and Y?
It's the first one.
Top
right?
left. Very top. Very, very, very
Ah.
top. Then go into plot 1.
Okay.
You're going to choose, first of all, make sure on is highlighted. Choose the first little graph icon.
Okay.
Hopefully you have it in list 1, list 2, because that's the default. If you don't have your data in there,
This is 6.
make it say list 1, list 2. And then hit graph.
9.
Got it.
Okay.
Mine's pretty
Why
scattered.
is mine not the same?
Should look like mine. Right?
Mine is just.
Similar.
Wait,
It's not going to be, I mean,
It's
if your
your
window is slightly different, could you mistake something. You shouldn't have a dot over there. Are we good?
Zoom 9.
We got our graph. Now, remember, you should make a sketch of any graph.
I even feel like got a problem.
He's a little bit special.
I always do the same I know, that's mine's in those three.
Is it?
Yeah, well. I don't know what those two. Whoa, whoa.
And so,
Dude, you so weird.
I grabbed
That's so
Yeah.
tough. Oh, you inside. Oh, yeah, inside. Ah.
That's what I'm saying.
Did you figure out your...
Yeah.
It's not perfect. I don't know. And I don't have time to figure it out right now. I'll look at it in a minute. All right. Did you guys make a sketch? Okay. Anytime you make a graph on your calculator, you should make a sketch on your paper. Because even though you have that, if I'm grading your paper or you're taking an AP exam, those people don't have the graph you have. So you always need to make a graph. A sketch. It doesn't have to be perfect. All right. Now you guys ready to find your R value using your calculator? So all phones are down. And we're listening because we have some buttons to press. Okay? I want you guys to quit out of your graph. So you're going to hit second mode. So you're in the home screen.
She forgot to clear.
We good?
Mine
Okay.
says L1 at the top.
Mine says
Hit
don't at
clear.
the top.
Okay. All right. You're going to go into stat.
Wait, what?
Stat. Just like you're going to your
That's
list.
calc.
But you're going to go over to calc.
Doing calculus? Is that
No,
what it is?
calculating. You're calculating
Oh, this is
information.
bad.
Now, the calculator, I don't know why. I honestly have no clue why. But number 4 and number 8 are the exact same thing. But notice It says lin reg. That means we're doing linear regression. Here with 4, it's ax plus b. So you have your slope times your x plus your y-intercept. Here you have your y-intercept plus your slope times your x. In statistics, for whatever reason, we do a plus bx. If you do number 4, it's going to give you the exact same answer. Just know that a is the slope, b is the y-intercept. Here, a is the y-intercept and b is the slope. Whatever's next to x in the little parentheses is your slope. I use 8 because in your textbook, that's the form they use, a plus bx. So either go down, highlight 8, or just hit the number 8. And then it's going to ask you what lists you're working with. Anybody on a 83? So on the 83s, remember they don't always prompt you for stuff. I don't know if that's going to work. We'll do. So bright. So if you have an older calculator, it doesn't prompt you for your lists. The newer ones, my information is in list 1. That's where I have the points per game. And then the wins are in list 2. So make sure you have your X and Y lists correct. Do not put anything in frequency list. I don't know why I struggle with that word sometimes. For today, we don't need to store a regression equation. I'll teach you how to do that on another day. And then you're going to go down and calculate. And it should give you 4 pieces of information. On the older calculators, Zach, list 1, list 2?
I think it's list 3 and 4 for some reason.
Okay. So whatever lists your data's in for older calculators, you're going to put your X list first, comma, your Y list, and then hit enter. And notice it gave the exact same stuff, just the older ones don't prompt you.
Mine's an 84, but it doesn't prompt.
Yeah, some of the older 84s won't prompt you. That's what I just said.
I know,
So where's your X data? What list?
1 and 2.
Okay, so list 1, second one,
Did we have to do like a comma?
comma,
Colin.
right above 7. List 2. All right, everybody get this.
Wait, see, I have a question.
Yes,
Never mind, I
are we good? Thumbs up. If you're, well, you had a weird point, so I'm sure you mistyped something somewhere.
But I'm gonna have to write all this down. Don't ever
I
remember.
apologize.
You don't have to, did you do list 1, list 2? Are you sure?
Oh, it's because you have list 2.
Yeah, I don't
Because that's the
There you go. You put wherever your data is, so you have 2 columns of data. So the first one is your X value, is wherever your data was
Alright.
that had X. So
We
that
good?
one was your Does that make sense?
So, our value, there's R squared and there's R. For now, we're going to focus on R. Towards the end of the unit, I'll teach you what R squared means. So our R value is 0.936 if I round. And then you guys are gonna, by the end of this unit, you're gonna hate it. We're gonna interpret a lot, okay? So you have to be able to interpret the value of R in context. So don't just tell me that R value of 0.936 is fairly strong. That's not an interpretation, I know that. Okay, you have to tell me what it means in the context of the problem. So for this one, like I've said before, I'm not a great grammar person, so if you can say it in a better way, say it in a better way. But I would say an R value of 0.936 points to a fairly strong positive, because my R value is positive, linear association.
How do you know?
Well, we looked at the graph. I didn't sketch a graph because I was trying to get through things quicker, but we had our data, it was something like this, right?
Is it the thing that's like?
It's positive, and it takes the shape of a line.
1.0, it's like the strongest.
Say that again, Hannah?
Is it the thing that's like if it's 1.0 it's the strongest? Or
Yeah, we're going to do that on the next page. So this is a fairly strong positive linear association, and this is where I put context, for points per game, because that was my X, and I'm going to abbreviate, and number of wins. Any questions? So we are going to talk about what makes our value strong, weak, positive, negative on the other side of the paper. Can I flip?
Right, well, Well, yes.
Thank you. All right. So, like I said, if your R is positive, that means you have a positive association. If your R is negative, that means you have a negative association. R lives between -1 and +1. They will, and when I say they, I mean the people who write the AP exam, they will throw questions at you like, what does a R value of 1.5 mean? And it's a trick question because R cannot be greater than 1 or less than -1. And somewhere in there should be an option that that's not an actual correlation value. There are trick questions about R, many of them. I've seen quite a few. You cannot have an R value less than -1 or greater than 1. If R is 0, that means you don't have a linear relationship. Remember, R measures linear relationships, not curved, not cluster, just linear. So if you get 0, there's no linear relationship between your data. If R is 0.3, we would say that's weak. Positive linear relationship. You should always talk about strength and direction and form all at once in these. Can I abbreviate relationship as REL?
Right.
Thank you. This one, I apologize, my negative kind of blends into the equal sign. But this says R equals -0.3. So it'd be the same thing. It's weak, negative linear relationship. Point 7, if R is 0.7, we would say something like fairly strong or moderately strong. It's not quite strong, but it's not really weak. So you have to have like a safety word in there. So fairly or moderately strong. It's a positive 0.7. So it's positive, linear relationship. If you get R equals 1, or really close to 1, like 0.99, 0.98, that would be a very strong positive linear relationship. I'm trying to think. I don't think I throw any examples at you where you get exactly 1, because that would be every point on the line, and that doesn't happen that often. And then of course, if you get R equals -1, that's a very strong negative linear relationship. And then down below, I'm going to give you some facts. And this set of facts is where they like to throw trick questions. Boys. Serious. Can I move it up? All right. And I will talk about how they'll use these facts to create trick questions. But these are where you really want to pay attention. So correlation makes no distinction between explanatory and response. So if you switch your X and your Y, you should, not always, but you should end up with the same R value. Biggest thing is both variables must be quantitative. And that is where they'll throw a trick question at you. They'll say, oh, the correlation between percent of teenagers who have their driver's license and gender is 0.7. Gender is not quantitative. So you can't have a correlation between the percent of teenagers and gender. You have to have two variables that are measured with numbers. So pay attention if they say, oh, here's correlation between this and this, make sure they're both actually quantitative variables. The units for correlation are none. There aren't units. R has no label. It tells us about our relationship, how strong, whether it's positive or negative, but you can't say that R equals 0.5 miles per gallon. That's not an okay statement. So that's how they try and trick you guys with multiple choice questions also. Correlation value does not change if the units for either variable are changed. So let's say you're looking at the relationship between hours studied and test scores, and you find an R value, and then you all of a sudden go, okay, let's change it to minutes studied and test scores. You should end up with the same R value. Doesn't matter that you took hours and converted them to minutes. You get the same R value. The correlation value R tells you the strength. So the closer to 1 or negative 1 you are, the stronger your relationship. But it only tells you the strength of linear relationships. If you get R equals -1 or +1, it does not imply that you have a linear relationship. That's why I said start with a graph. You can end up with a curved scatter plot that has an R value of 1. You always should look at your graph. The correlation value R is non-resistant to outliers, which means that it gets affected by those outliers. And we will look more at that further in this unit. Sorry, my big handwriting, I ran into the word. Let's go with vulnerable. Vulnerable. I haven't used that word in a while. So outliers are going to really affect R. My husband's psych kids, correlation does not imply causation. So just because you have a relationship between two variables does not mean that one variable causes the other to happen. Correlation is not a complete summary of two variable data. And you guys will learn that quickly. There's about 4 or 5 other things that we use. We find R squared, we find S, we find residuals, lots of different numbers we're going to find to help us describe two variable data. Questions? Can I flip?
Yes.
I see a couple people still writing, so I'm going to wait just a little longer. So on the back, we're still working with that points per game, number of wins data. I printed out the scatter plot for you. Oops, sorry. There we go. So the data that we had back here that I had you guys put in your calculator, you made the scatter plot, we found the R value. This is still that data. So it tells you points per game, number of wins for a college football team in the SEC. We found the R value, bless you, was 0.936. I don't know why I put that there again a second time. We did that on the previous page. So maybe make a note on the other page. I didn't proofread well. You guys will learn that. I'm not a good proofreader. What I want to talk about is the point highlighted in red, which it's not red because I didn't have a color copier, but it's that bottom one that has the halo around it. Is Mississippi, and if we go back and look, I know you're trying to wake him up. Mississippi is right here. They had 16 points per game, but they only won 2 games. We want to see what effect Mississippi has on our correlation. So before we do this, anybody want to make a prediction? If we get rid of Mississippi, is our strength, our value going to get closer to 1 or further away from 1?
Closer to
How many of you say closer to 1? Isn't that what you said?
what?
You said closer to 1.
I'm not going to
And
raise my hand. I'm the only one.
there were 2 other people.
Oh.
How many of you say further away from 1?
I'll go with the majority.
You already raised your hand. Stop throwing pieces of paper unless you're going to pick them all up.
I'll pick
All right, so let's see what happens. Let's go back in. So we know how to find R. Let's go back into our list. You're going to edit your list, and you're going to get rid of Mississippi. So scroll down. Mississippi is 16.1. Hit Highlight 16.1. This time is when we actually hit delete.
You also get rid of 2.
Yes, and then you also need to get rid of 2 in your other list. And hit delete.
Wait, so you get rid of
Oh,
2 and what?
16.1 and 2. And then this gives you another opportunity to practice finding R. What buttons do we press to find R? Stat, Calc, 8. Because that's what your book uses, so I suggest that one. List 1, list 2, calculate. And I get R equals 0.918. So when we get rid of Mississippi,
Did not get that.
Yeah, that's what I got.
when we get rid of Mississippi, our R value goes down, or the strength of our linear relationship decreased. Which makes sense, right? Because Mississippi kind of helps make our line straight. When we get rid of Mississippi, we have more of a curve to our data.
Oh, I thought Mississippi was an outlier.
That's something like this.
When I was kind of sleeping, there was a girl in my dream called Mississippi. Just because he kept saying Mississippi.
That's great, Hayden.
Nice. That's not okay.
Does that pass? So when we got rid of Mississippi, we went from 0.936 to 0.919.
Dude.
Or without.
Without Mississippi, with Mississippi. Questions?
Is that like a valid answer on the AV test?
That?
Like the R with this, R without.
Yeah.